This is the B1C1 P1 higher past paper 5 run through. Remember, you've always got these equations at the front of your paper. If needed, they're usually useful for the physics section. We're starting with the biology section. So first question is, Deb is 13 years old. Her doctor has told her that she must eat enough protein each day. She can calculate her estimated average requirement for protein in grams using this formula. Deb has a mass of 58 kilograms. Use the information about how much protein Deb eats in one day. Or look at it, sorry. Does Deb meet her EAR for protein? Is EAR an accurate measure for protein requirement? So first thing to do is work out what her EAR is. So you can see here's the formula. Her mass is here. She's going to do her EAR equals 0.6 times her mass, which is 58. And that gives you 34.8. And then you need to work out her total protein intake, so add all these together and that gives you 32.4 grams. And this is worth 3 marks. So there's your first 2 marks, working out her EAR and then working out how much she's taken in and therefore saying that it's less than EAR. So Deb eats less than her EAR. And then the last mark is to talk about whether it's an accurate measure for protein requirement. So any of these would get you that final mark, or so either of these, sorry, say not accurate because it's only an estimate for an average person, so the idea that it's just for an average person, or it's not accurate because her EAR will vary with age. So Deb is 13 and therefore a teenager, and her EAR will be bigger than the average requirement because she's growing. Next question, so the doctor also tells Deb to make a note of which proteins are animal proteins and which are plant proteins. He says that animal proteins are first-class proteins. What does that mean? Or, sorry, why are animal proteins called first-class proteins? And that's because it contains all the essential amino acids, or it contains amino acids that cannot be made by the body. So either of those, the easiest one probably is just to say that they contain the essential amino acids. Question 2, the diagram shows a part of a human eye. Describe the job of the cornea and the lens in vision. So there's 2 marks here. So the first mark is saying that they both bend light, or they both refract light, or they both focus light. And the second mark is for saying that the lens focuses the light onto the retina. So those are your 2 marks. And then look at the graphs. They show how pupil size, the diameter, changes with the age for 2 levels of light. So diameter is this. If you've got a circle, then the length across the circle from edge to edge. So you've got low light level, high light level. It says what conclusions can be drawn from these data and what are the implications for elderly people. So there's 4 marks here. So first mark is saying that increasing age decreases the size of the pupil for both levels of brightness. So in both low light level and high light level, as you increase in age, the pupil size decreases. And then you could say that in dark conditions there is a greater difference between the old and the young. So in low light levels you can see if you're there's a greater difference between the top and the bottom than in high light level. Which means that for older people it is difficult for enough light to enter the eye in dark conditions, which makes it difficult to see or read in dark conditions. And so that could be 3 marks. And the 4th mark saying that older people have smaller changes in pupil diameter in response to changes in light, which means that older people will not be able to see very well when going from bright to dark conditions. So quite a difficult question that. So first mark is for saying increasing age decreases pupil size. Second mark saying that in dark conditions there's a greater difference between old and young. And then next mark is saying, therefore, older people find it more difficult to read or see in dark. And then last mark is for saying that older people have smaller changes in pupil diameter in response to the changes in light. Tobacco smoke can affect many systems in the body. Carbon monoxide in the smoke can cause an increase in blood pressure. Explain how carbon monoxide can cause an increase in blood pressure. So there's just one mark for this question, and it's just that the carbon monoxide means the blood can carry less oxygen. It makes the blood carry less oxygen. So that means the heart rate has to increase in order to get the same amount of oxygen around the body. Tobacco smoke can also affect the lungs. The graph shows how well the lungs work at different ages. This is shown for two groups of people. One group is heavy smokers, the other group is non-smokers. The dotted line shows the possible effects of stopping smoking at age 48. So there's the graph. And here's the question. So it says, Doug is a 40-year-old heavy smoker. If Doug decides to give up smoking, the age at which he is likely to become disabled increases by 20 years. Explain this difference in age at which Doug would become disabled. Use your knowledge of the effect of smoking on the lungs in your answer. 2 marks. So first mark saying that smoking causes damage to the cilia, which means chemicals build up and can cause cancer. And then second mark saying, but giving up prevents further damage to the cilia or less build-up of chemicals, so reducing risk of cancer. You could also talk about emphysema if you wanted to. To get those marks, your answers have to link to giving up. Link giving up to cancer to get both the marks. Doug continues to smoke because tobacco contains an addictive drug called nicotine. This drug is also a stimulant. Explain how nicotine affects synapses in Doug's body. So 1 mark here, just saying that it causes more neurotransmitter to cross the synapse, or increases the chance of nerve impulse being passed, something along those lines. Next question, Fred has cystic fibrosis. He finds it difficult to breathe because there is too much mucus in his lungs. Cystic fibrosis is an inherited condition. It is caused by a recessive allele. Neither of Fred's parents has cystic fibrosis. They want to have another child. What is the probability of their next child having cystic fibrosis? Draw a genetic diagram to explain your answer. So, this is where you draw this sort of diagram. And you've got to use information to determine whether you're using 2 capitals or a capital and a small letter or 2 small. So this is caused by recessive allele. It says Fred has cystic fibrosis. It says neither of Fred's parents have cystic fibrosis. So this must mean that they only have one of the recessive genes. So there's both of Fred's parents. So this is the way that they could, that their alleles might combine, and you can see that only one of them have 2 recessive genes, which is where you have which will cause cystic fibrosis. So this is a 1 in 4 chance, or a 25% chance of getting cystic fibrosis. Fred gets a lot of chest infections. When he gets a bacterial infection, his doctor gives him antibiotics. Fred's doctor could just give antibiotics all the time as a precaution. However, doctors are careful not to use antibiotics more than necessary. One reason this is not to waste money. Write down one of the reasons, and this is to prevent resistance to antibiotics. So prevent bacteria from getting resistant to the antibiotics, and therefore the antibiotics not being able to work. So if you just said something about bacteria being able to develop a resistance, then that will get you that mark. Chest infections can be caused by different types of bacteria. Tests were done on 100 patients with cystic fibrosis. The tests involved taking a sample from each patient and finding out which of these 3 types of bacteria are present in their system. The bar chart shows the results of the tests. There they are. Can you tell from these data how many patients have more than one of these types of bacteria in their system? Explain your answer. So there's no mark for saying no, but the answer is no. But the marks are explaining. So you could say something like, because some patients have more than one type of bacteria, since the percentages for the 3 types add up to more than 100%. So the idea that these add up to more than 100%, which means some patients must have more than one of these. And then the second mark saying that you don't know how many patients have more than one type of bacteria because the data doesn't show the percentage with no bacteria. So some patients have no bacteria, and the fact that that's missing means you can't work out which ones have more than one type. This next question is a 6-mark question, which I'd like to mark yourselves using the mark scheme you can find on the Blue Coat Science Google site, the website for which is on the bottom of your poster. If you're unsure whether you've marked it correctly, please ask your teacher and they'll be able to check it for you. So next section is the chemistry section. First question is about esters. So esters are useful substances. They can be used to make perfumes and solvents. Look at the list. Complete the word equation show how an ester is made. So you react an alcohol with an acid, which will make ester, and you also make water. So you need water in there and alcohol in there. Perfumes and drugs can be tested on animals in some countries. Write about one advantage and one disadvantage of testing drugs on animals. So an advantage is that the test is more realistic as animals are alive, and the disadvantage would be that it's cruel to animals. You could also say that disadvantage is that animals are not the same as humans, so their skin may not be the same and may not be affected in the same way. Phil wants to choose a fuel to heat his house. 2 important factors Phil needs to think about when choosing a fuel are the cost of the fuel and the energy released per gram. Suggest 2 other important factors which Phil needs to think about. So you can have any of these, so 2 of these: availability, or how easy it is to get hold of, or how long will it last. Flammability, so how easy is it to light the fuel, or does it have a clean flame? You could say how much space it needs to store the fuel, so storage. Can the fuel be used safely, or is the fuel toxic? Will it produce poisonous carbon monoxide when it burns? So any of those. The way that I've taught my students to remember this is with the word CATSP. So CATSP stands for cost, availability, toxicity, storage, pollution, efficiency, and energy content. Now obviously the cost is already in the question and the energy content is already in the question, so you can't have those 2, but you could have any of those other 5. Look at the graph. It shows how the percentage of carbon dioxide in the air has increased to give 2 reasons why this has happened. So any of these 2, population has increased, there's a higher demand for energy, or increased burning of fossil fuels, or increased industry. You could say because of increased deforestation. You could say there's a high demand for fuel in emerging economies like China. You could say more transport, cars, more electrical appliances. So any of those would get you, any 2 of those would get those 2 marks. Phil wants to heat his greenhouse. He decides to test 4 liquid fuels to see which fuel is best to use. Look at the diagram. There it is. Shows how he's testing the fuels. Look at the table. It shows the results. It says Phil decides to use fuel C to heat his greenhouse. Evaluate if this is a sensible choice. So the word evaluate means to give a for and against, and then your own conclusion as to whether you think it's a sensible choice. So a for could be that it's the cheapest, if you look. So it's the cost is the cheapest out of the 4 fuels. So I'll get your mark. And then if you work out the temperature differences, this one is 15, this one is 20, this one is 5, and this one is 10. You can say that it's not the best fuel because it's got the lowest temperature difference, so it gives out the least energy. So B would be the best for giving out the most energy. And then you could also look at the temperature rise per penny. So this is one you get 15 degrees per penny, the next one 10. Fuel C you also get 10, and the last one you get 6.7. So then you could say that A, therefore, is the best fuel because it has the highest temperature change per penny. So you've got 3 kind of factors there that you'll get a mark for. First one saying that fuel C is the cheapest, then saying that fuel B has the highest temperature change, then saying fuel A has the highest temperature change per penny. This question about carbon compounds, look at the displayed formulas. There they are. What compound is a saturated hydrocarbon? So saturated means that it has no double bonds between carbon atoms. It has all single bonds. So propane is a saturated hydrocarbon. Which compound will decolorize bromine water? Bromine water test is a test for alkenes, so ethene will decolorize bromine water. And then we'll write down the molecular formula of methanol. So for molecular formulae, all you have to do is count how many of each letter there are, and then write a small number of how many there are afterwards. So you could put C, and there's only one of them, so you have to put a number after it. H, and there are 1, 2, 3, 4 H's, and then O. So look how I've put the number. It's slightly lower down and smaller. These letters can be in any order, so you could have had OH4C or H4CO, and so on. Polychloroethene is a polymer. Look at the displayed formula for polychloroethene. Polychloroethene is made from a monomer called chloroethene. Draw the displayed formula of chloroethene. So here's polychloroethene. So all you've got to do here is take off the brackets, put a double bond back in between the two C's, and then draw what's around it like so. So that is the displayed formula of chloroethene. This question about the gases in the air, look at the pie chart. It shows the composition of the air. What percentage of the air is oxygen? So don't use the pie chart to work it out, because you've got bits there that aren't oxygen. You've just got to remember that it's 21%. But actually, if you put 20% or anything in between, you'd get the mark. Carbon monoxide is a pollutant in the air which made when petrol burns in car engines. A catalytic converter removes carbon monoxide from the exhaust gases of a car. Describe with the aid of a balanced symbol equation how a catalytic converter removes carbon dioxide. So carbon monoxide is reacted with nitrogen monoxide to make carbon dioxide and nitrogen. And then you need to balance it like so. And the second mark, so that balancing equation will get you the first mark. The second mark is for explaining that carbon monoxide is therefore converted into carbon dioxide by the catalytic converter. Nitrogen and oxygen do not normally react with each other. However, with a car engine, nitrogen and oxygen do react to make nitrogen monoxide. Explain with the aid of a balancing equation why nitrogen and oxygen react in a car engine. So first, you've got to write the symbol equation. So it's just nitrogen plus oxygen makes nitrogen monoxide, so you just need to balance that with a 2 in front of there. And then the reason why they react is because of the high temperature in the engine. This next question is a 6-mark question, which I'd like to mark yourselves using the mark scheme found on the Google site, and ask your teacher if you're unsure whether you've marked it correctly, but have a go yourself first. Last section is a physics section. So first question, Asif has an old gas fire that heats the living room of his house. The label on the gas fire states that it's 60% efficient. The energy in a year's gas supply for the fire is 1500 megajoules. Draw a Sankey diagram for Asif's gas fire. Add labels to show how the energy is used. So a Sankey diagram is just, you've got to draw arrows, and one showing the wasted energy and one showing the useful energy. So you've got 1500 megajoules going in. It tells you the efficiency is 60%, so therefore 60% will be coming out as useful energy. So that's 900 megajoules. You can work that out by doing 1500 times by 0.6, which equals 900. That means there must be 600 megajoules of wasted energy. So there's 2 marks for that, and then saying useful energy here and wasted here will get you the 3rd mark. Asif changes his old gas fire for a new one because he thinks a more efficient fire will save him money. Look at the data in the table about the new gas fires. There you are. Asif plans to keep the new gas fire for 10 years. The salesman recommends that Asif buys a model with the highest efficiency. Asif considers the payback time for each gas fire and the saving on fuel cost. Which model of gas fire should Asif choose? So the answer is the concept, but that won't get your mark. The mark's for explaining why. So the reason is that the concept is the only one with a payback time that is less than 10 years. And so this means that Asif will save the most money, which will be £100, over the 10 years. Or you could say because the concept is the only model where the payback time is less than 10 years, so over 10 years, ASIF saves the most money with the concept. So if you look, if you work out the payback time for them all, payback time is the cost divided by the yearly saving. So this one's going to be 900 divided by 80, which is over 10. This one's going to be 600 divided by 70, which is less than 10. This one is going to be 750 divided by 50, which is 13. 475 divided by 45, again more than 10, and 850 divided by 70, more than 10. So the concept is the only one that has a payback time of less than 10, and therefore he'll save the most money over the 10 years, which is the important thing. Sue looks up some information about the specific latent heat of water. Sue is heating 100 grams of ice. Look at the graph, it shows Sue's results. Calculate the energy which is supplied to the water between points A and B on the graph. So there are a few facets to this question that you need to realise. First thing is to recognise which one of these, which change of state A and B is. Well, there's two changes of states in this graph. So the first one must be melting, and the second one must be evaporating or vaporisation, boiling. So this is the number you need to be using. Then you've got to realise this is in kilojoules per kilogram, whereas this is in 100 grams. So remember, specific latent heat, to work out the amount of energy supplied, you multiply the mass by the specific latent heat. But you've got to make sure they're in the same units. So you've got to do 100 divided by 1,000 to convert it into kilograms, which equals 0.1. Then you do 0.1 multiplied by the specific latent heat, which is 2,260. And then to get both marks, you've got to put the answer, which is 226 kilojoules. Now, if you only wrote 226 kilojoules, that would still get you both marks. You don't need the working in order to get the marks. Energy is supplied between A and B. Explain why the temperature of the water does not change. So this is because that the energy supplied is used to break the bonds. So that's worth 2 marks. The energy supplied is used to break the bonds rather than change the temperature of the water. This next question is a 6-mark question, so please mark your own and then ask your teacher just to check it, but make sure you mark your own first using the mark scheme that's on the Google site. Next question. This question is about electromagnetic waves. Look at the information about 3 types of electromagnetic waves. Fill in the 2 gaps in the table labelled A and B. So A is infrared, and B is radio waves. You need to have both those for the 1 mark. Microwaves are part of the electromagnetic spectrum. Microwave radiation is used in cooking and also in communications. David reads the label on the back of his microwave oven. The speed of microwaves is 3 times 10 to the 8. Use information on the label to calculate the wavelength of these microwaves. So remember that wave speed equals frequency times wavelength. So to work out the wavelength, you need to do the speed divided by the frequency. Now this is in the equations at the front of your booklet, so you don't have to remember that. You just need to be able to rearrange it. So that's going to be 3 times 10 to the 8, so 3 with 8 zeros after it, divided by the frequency, which is you're told there, so divided by 3.44 times 10 to the 9. And that will come out at 0.09, which is 0.09 meters. Use the data in the table to estimate the energy of microwaves with this wavelength. So any answer between 1 times 10 to the minus 23 to 3 times 10 to the minus 24 will get you that mark, any answer between those. Lucy's father is deciding whether or not to buy her a mobile phone. He is concerned there may be health risks associated with using a mobile phone. Give an example of potential health risk and describe how Lucy's father should evaluate the risks when making his decision. So you get a mark for a risk. So any of these two. So it might be cell damage to the brain from heating effects of the microwaves, or which could then lead to possible increased risk of brain tumours. If you said that you might have an increased risk of brain tumours, or there's cell damage to the brain, you get a mark. Then you get a mark for ways of limiting the risks. So risks can be reduced by using a speakerphone, or headset, or you could reduce risk by only using for short conversations, or you may then you need to say that the risks may be offset by the benefits of using a mobile phone. You could also say that there is not enough evidence to support these risks as well. So any three of those things that I've said would get you those 3 marks. And the final question, the Montreal Protocol in 1987 set up an international agreement to phase out the use of CFCs. Explain why this ban on the use of CFCs is necessary and why it has to be internationally agreed. So first mark saying that CFCs have depleted the ozone layer, and then saying the depletion of the ozone layer allows more UV light to reach the Earth. So there's your 2 marks. And the last mark was saying that all countries must stop, and that's why an international ban is needed. You can't be solved by just stopping 1 or 2 countries. All of them have to stop using CFCs in order for the ozone layer to regenerate itself. Add up your marks, add it to your poster, and then try the next one.